Good day, everyone. We discussed on our last video about scheduling in terms of SQL Server. We will continue on the same topic on this video too. Let's get started. What is a scheduler in terms of SQL Server? Scheduler means presenting one thread per CPU. This implies that we will have one scheduler for each available CPU on the database server. Even though SQL Server utilizes non-preemptive scheduling, but the underlying scheduler on the Windows server, which is basically your CPU, will be preemptive as Windows uses preemptive scheduling. Preemptive scheduling works with respect to the priority of the thread. All SQL Server thread will have a normal priority, and it can be bumped to real-time by selecting Boost SQL Server priority option. I'm discussing this just for information, but we never do this as increasing SQL Server thread priority might hinder important Windows thread, and this could lead to availability issues. That is, SQL Server might go down, or you might be seeing some sort of situation where you are getting dump files created. As far as Windows is concerned, higher priority threads can preempt currently executing lower priority thread and can schedule itself on the CPU, and this can lead to some thread starvation. But as far as SQL Server is concerned, all its threads will have same priority. SQL Server will beautifully schedule threads across scheduler uniformly without worrying about some schedulers having more and other schedulers having less threads. We have an algorithm that can perform worker switches on latest version of SQL Server during edge cases where some schedulers can have more threads, and some of those threads from those schedulers, which is having more number of threads, will be transferred to a scheduler that has fewer threads. SPIDs or session IDs that are in suspended state implies that those threads are on waited list till the time they are waiting on something. Let's talk about yield condition generally for a SQL Server thread. A thread can yield if it fetches a database page. The worker execution quantum is checked. If it exceeds the 4 milliseconds quantum, then it is basically yielded. The thread yields at every 64 kilobyte count of sort records. A thread can yield if it is going to make an external call to an extended store procedure or link server. A thread can yield if the client cannot fetch results as fast as they are returned. A thread can yield if it is forced to wait on a latch. A thread again can yield if it completes the run of each statement in a batch. Let's consider a situation where there are no workers on the SQL Server runnable queue. The worker that basically yields from the Windows CPU is allowed another quantum or performs the required idle scheduler maintenance or the janitor task as mentioned before till we see new thread on the SQL Server runnable queue. Moving on, let's talk about scheduler, task, worker, thread, request, sessions, and connection. So scheduler, also known as SOS scheduler, this object that manages thread scheduling in SQL Server and allows thread to be exposed to the CPU. You can get the details of the scheduler by querying dmv sys.dm_os_schedulers. This is the all-powerful master whom everyone abides to. Scheduler does not control things, but lets the workers work with each other and relies on their cooperation. It is also called cooperative scheduling mode. Each scheduler, which is one per logical CPU, accepts new tasks and hands them off to the workers. SOS scheduler also allows one worker at a time to be exposed to the CPU. Tasks. A task represents the work that needs to be performed, and you can look at these tasks by querying the DMV sys.dm_os_tasks. A task contains one of the following events: a query, RPC event or a language event, a pre-login, kind of a pre-login event, a login, a connect event, a logout, it's a disconnect event. A query cancellation can be an attention event, a bulk load, which is a bulk load event, a distributed transaction, which is a transaction manager event. A task is what the master is about. It is what defines its existence. Note that these are tracked at the SOS scheduler layer. Let's talk about the worker, that is the worker thread. This is logical SQL Server representation of a thread. Maybe think of it as a wrapper on top of the OS thread. It is a structure within the scheduler which maintains SQL Server specific information about what a worker thread does. Querying DMV sys.dm underscore OS workers gives a list of worker. Workers are the humble servant who can carry out the task assigned to them by the scheduler. Let's talk about the thread. This is the OS thread that could be found querying by the DMV sys.dm underscore OS underscore threads that is created via calls like create thread or begin thread EX. A worker is mapped one-to-one to a thread. Let's talk about request. Request is the logical representation of a query request made from the client application to SQL Server. You can check the request by querying DMV sys.dmexec underscore request. This query request has been assigned to a task that the scheduler hands off to a worker to process. This represents query requests as well as system thread operations like checkpoint, log writer, etc. You will not find login, logouts, attentions here. Also, note that this is a representation at the SQL execution level and not at the SOS scheduler layer. Let's talk about sessions now. When the client application connects to SQL Server, the two sides establishes a connection or a session exactly on which to exchange information. Strictly speaking, a session is not same as an underlying physical connection. It is a SQL Server logical representation of a connection. But for practical purposes, you can think of this as being a connection. You can query sys.dm underscore exec session to get a list of sessions. This is the old SPID, session process ID, that existed in the SQL Server 2000 and earlier. In the case of system sessions, that is the internal session spawned by SQL Server like lazy writer, checkpoint, log writer, service broker, etc. No external physical connection is mapped to the session. Only a session ID exists, typically reserved for session IDs less than 50, but can be a higher value too. You may sometimes notice a single session repeating multiple times in a DMV output. This happens because of parallel queries. A parallel query uses the same session to communicate with the client, but on the SQL Server side, multiple worker threads are assigned to the service this query request. So if you see multiple rows with the same session ID, know that the query request is being serviced by multiple threads. A session ID or a SPID is used to identify the work performed inside SQL Server. For example, you may want to find out which session ID is executing a query or which session ID added query cancel. Some of the property of a session include login time, last request time, CPU consumed, memory consumed, and total elapsed time used by a query or set of queries on this session. Username, set options configured for this session. Let's talk about connection now. Connection is the actual physical connection established at the lower protocol level with all of its characteristics. Querying sys.dm underscore exec underscore connections gives details of the connections. There is a one-to-one mapping between a session and a connection. A connection has some of the following properties like protocol, shared memory, TCP, or named pipes, authentication type, either NTLM or Kerberos, encryption, either switched on or off, network packet size, client IP address and port. These are all physical properties of the connection. A connection underscore ID in sys.dm underscore exec connection is a GUID and is used to uniquely identify the physical connection. You typically won't use a connection underscore ID to identify which session is executing a query, as session ID is comfortably used instead. Let's now discuss how all of the discussed components previously work together. So a client application creates a physical connection to the SQL server. Then the application sends a pre-login request and the task is created and assigned to a worker to fulfill the required task. Once the server and client finishes the pre-login process, a login request is sent and another task is formed and handed off to a worker thread. Once the login is completed, SQL Server creates a session that represents this logical connection where it will exchange information with the client. When the client application sends a query request, the server again creates a task and assigns it to a worker thread for completion. If the query is cancelled in the middle of the execution for some reasons, the server will receive an attention request upon which the IOCP listener will mark a bit that the query is cancelled and the worker that was running the query would stop executing when it sees this particular big set. If the query is allowed to complete, on the other hand, the client application is done. It can send a disconnect or logout request, which again is packed as a task and serviced by a worker. We will speak about non-yielding schedulers on my next video. Thanks for watching. Have a great day. Jai Hind.